Hello, hello, hello. So this question is about, let's get a pen. What color do you want? This color is this pen. This is all about centripetal acceleration and centripetal force. Okay. So we've got a rotating pin. So all it is really, let's pretend here's my center. Here's a pin. Okay, that's the pin. Okay. And it's rotating. So it's going like that. Rotating at 2.2. So angular velocity is 2.2. The mass of this thing, this pin, just something spinning, the mass of it is 0.53. And the length of it really, so this length here, because it says, so the mass of the pin is 0.53 and its center is 200 mil. So this here, this length here, 0.2 of a meter. And then this bit's meant to be like the crankshaft. So it's attached to that. That's spinning, which makes this thing spin as well. So all we need to know is that this is a bit of metal spinning. So if it's spinning, it's got a thing called centripetal acceleration. It's also got a thing called centripetal force, which is opposite to centrifugal force. So we've got to work out, first of all, number A, we've got to find centripetal acceleration. I'll use a symbol AC. Centripetal acceleration. So there's two ways we can work that out. There's two formula. We can either use omega squared times r, where omega is the speed in radians per second and r is the radius. Or we can use AC is also equal to v squared divided by r, all depending on what we know. Okay. So we know green. So we know that the angular velocity of this thing is where is it? 2.2. 2.2 is that 2.2. That's going to be, so we know that 2.2 radians per second. And the radius, well, this is the radius in it. That's how the radius of this, because this thing is spinning in a circle. So this is our radius of motion, which we know is 0.2. So r is going to be 0.2 of a meter. Both in the right units, both in radians per second and both in meters, everyone's a winner. So I might use this formula here. I can use this formula, but I have to work out V. I don't want to be working out V because I might make a mistake. So we could use this formula, but I don't know what V is. So I'm going to use this one. Oh, I'll use this one. So centripetal acceleration is omega squared times r. And I know both of them. I'm going to scroll down here. Get a different color pen. Get a different color pen. Go for red. So centripetal acceleration is going to be omega squared times by radius. So omega squared is here. That's going to be 2.2. Don't forget it's squared, right? It's squared times by the radius, which is here, which is 0.2. So if you whack that in your calculator, you will get the centripetal acceleration. That comes out to be something like 0.968 radians per second. That is the centripetal acceleration. Different color. There, look, this number here. That's part A. So part A is done. We've got centripetal acceleration of the pin. There, so that's part A done. There, look, part A, happy days. And then part B, we've got to find the centripetal force on the pin. That'll be part B coming next. So part B, we've done part A. So part B, now I'm going to get some colour pens, green. So part B, we've done part A. Part B, we've got to do centripetal force. We've done part A, we'll tick part A off. We've done part A down the bottom. We've now got to do centripetal force on the pin. This thing is spinning, this thing is spinning, so it's going to have a centripetal acceleration and a centripetal force, which is opposite to centrifugal. Okay, so we've got to find now the centripetal force. And that's the force, really. There's my center, there's my pin. It's the force coming down I got. That's going to be my pin. Right? That's what that is. Okay, so it's the centripetal force. It's opposite to centrifugal, which you might know what centrifugal is. A couple of formulas you can do for this. Centripetal force is either mass omega squared r, where m is the mass of our pin, which we know. Omega is the angular velocity, which we know, and r is the radius, which we know. So I might want to use that formula. Or we could use another one, mv squared over r. Okay, now I know what m is, I know what r is, but I don't know what v is. So I can't use that one. I've got to use the one that I know everything. So I've got to use this one here. So I know the mass, and I know the angular velocity, and I know the radius. The mass is up here somewhere. There's the mass, 0.53. Everyone's a winner. Kilograms in the right unit. Okay, I know the angular velocity because it's up here somewhere. 2.2. 2.2. Radians per second, best. And the radius is just the length of this pin. It's the radius of this circle, really. And that is going to be 0.2 because it's 200 mil, which is 0.2 of a meter in my book. So R is going to be 0.2. Don't forget there's a square there. So what we've got to do, we get rid of this formula because we don't need that one. So let's get a different color pen. Different color pen. So FC, centripetal force, is going to be mass, which is 0.53, times by angular velocity, which is 2.2, don't forget the squared, times by the radius of the pin, or the length of the pin, 0.2, 0.2. Put that in your calculator and you will get the centripetal force on this pin. It comes to be 0.51 newtons. That equals the centripetal force. And what that means is, this is my shaft spinning. And then we've got this little pin on here, look. All that means is, we've got a centripetal force. There's a force going that way. Okay? That's the centripetal force. You might know centrifugal because you feel centrifugal when you go around a bend. Centrifugal force is the equal and opposite to centripetal, and that goes that way. Centripetal, centrifugal. Okay. But all we had to work out was centripetal, which is 0.51 newtons. That's our centripetal force. So that is this one, look, centripetal force. Ready, Benny, done. 0.51 newtons. And our centripetal acceleration from before was 0.968. So part A and part B done. This is part B. That one there, look, done. Tick, 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 smile. So all we've got to do now is part C. The last part is part C, which is the RPM. Okay, revolutions per minute that the pin is rotating at. So that's part C coming up. So part C, not part C, part C. So part C, we've got to find the RPM of rotation. Rotation. Okay, that just means, here, look. So we've done part B and we've done part C. So the last bit is to do what RPM is this pin spinning at? Well, we know it's going at 2.2 radians per second. Okay, we know that, but we want to convert that into RPM. So we know it's spinning at 2.2 radians per second, but we want to convert that into an RPM. Because most things, although radians per second is the unit of angular motion, you will probably see it more often as an RPM, revolutions per minute, in your car, on your lathes, in the workshop. Okay, so there's a little conversion factor to do that. So we know that to go from an RPM, revolutions per minute, into radians per second, we've got to multiply it by 2 pi over 60. That's the conversion rate. The 2 pi bit, because one revolution of a circle is 2 pi radians, and there's 60 seconds in a minute. Seconds in 1 minute. So this little thing here will do the conversion for us. The 2 pi bits gets it into revs, revolutions, and the 60 gets the seconds. That's the minutes, sorry, the minutes into seconds. So if I had, I don't know, 20 RPM, if I multiplied that by 2 pi over 60, I would get it in radians per second. Okay, and if I had 20 radians per second, I've got to divide that by 2 pi over 60 to get RPM. This will give me radians per second, and this will give me RPM. So if I want to go from RPM to radians per second, I times it by this thing here. If I want to go the other way, I've got to go back, so I've got to divide. So we've got, what have we got? We've got rotating at 2.2 rads per second. So we want to go from rads per second to RPM. So we've got 2.2, sorry, 2.2, come on. We got to go the other way. So we've got 2.2 radians per second, and we want to go into RPM. Okay, so all I'm going to do is divide it. Because to go from RPM into radians, I times it. To go from radians per second, I divide it. So that's what we want to do. 2.2. Divide that by 2 pi over 60. Do that in the calculator. This will give us the revolutions per second. And the answer you get, because something went wrong there with the computer, the answer you get is about 21 RPM. That's part C done. Okay, so all I've done is 2.2 divided by 2 pi over 60. So that gives me 21 RPM, which means that's part C. And this is 21 revolutions per minute. Part C done. Okay. That's all we've got to do. So that is centripetal acceleration, centripetal force, and RPM of a rotating pin in a car. A, B, and C, all done, all the right units, all the right calculations, everyone's a winner. So for now, over and